Welcome to a Fresh Thinking video on a reference architecture. This is related to the work we do in Fresh in developing strategies for customers and to have a destination architecture. This is not focused solely on IBM I, it's focused on a modern IT architecture. We are socializing this so that the conversation can continue and that people in the IBM I world can see something a little more modern and understand that we can do all of these things with IBM I, which is really quite fabulous. So a short history. We've done a couple of things. This was earlier on. This was last year. We did a multi-tiered architecture. We put a gateway in the middle of that. I won't go into a lot of it, but it was very helpful to do that. Then we talked about having the yellow part being the plumbing between all of the different kinds of siloed architectures that you might have as well. And that got to be confusing. Some people thought that might be you have to have plumbing for everything. No, you only need plumbing for the little bits. We'll talk about that last in this session. We went out to what Microsoft thinks is an architecture, and this was really informative. It's actually quite a lovely architecture, and we learned some amazing things, especially that word cross-cutting, which we'll come to as well. And then just another view of that. It's pretty fascinating, and I'll put those links in the bottom of this video. So very interesting. It sort of helped us prove that we were on the right track, that this was not just for us, that it's for everybody. And if you're interested, go look at some of this stuff out on the web. And then a much more deeper one. Obviously, this is the worst slide on the planet.
It's only a little busy, you know.
Yes.
The nice thing is you can put that up and you can talk to that slide for hours.
Hours, yeah. And some people actually animate it to bring in each little bit at each time. So anyway, so let's talk about an IBM I native architecture from the top down. And this is the big picture of it. To introduce it, I'll go through each of the steps. So we start with the database layer for the architecture, and it includes, obviously, the tables, modern SQL. This is not something we consider physical files to belong to anymore because a modern architecture includes SQL, which is tables. And of course, underneath that layer supporting that are the indexes that we need, and they will be built over time. And above the tables themselves will have the views. So you only access data through views. You do not access it directly in the table. So that's why there's a cap on each of those tables. And there will be multiple views for tables depending on what you're building and how you're moving forward. The next layer is the database services layer, where for each of the views, and potentially just for the tables, depending on so this is an architecture. It doesn't dictate and require you to have any of these things, but generally we have a CRUD, create, read, update, and delete service that is available, and then a list service, and then potentially some other services to do other things we might want to do with this database as well. Generally, CRUD and list cover the majority of what you do. Above that are the business processes layer. And these are all services that there are a ton of different things that are utilities that are available for multiple things. Maybe you might have a utility that would calculate some tax thing, or another one would be a utility that would consume a service on the outside that would get the, for the US, it would get the state and the town for a particular zip code, and maybe the county as well. So those kinds of things. Then business rules, maybe I have a calculation of a rate for a tax rate or an insurance rate or something. I might have a business rule for that. That's here. And then the other big ones are generally the transactions. So at this layer, we don't look at things like a header and detail file like you might have. We look at them like the whole order or the whole transaction, the transaction of the entity. And then orchestration. Maybe we want to run several of these different business rules together to do some function. So a higher level of granularity of service, and we might have that as orchestration services to do many things. On top of that, we'll start with the user interface layer, and this could be directly on IBM I. What we've discovered is for green screen people who want to continue doing that because they have a tool above that to take it to the web or to the desktop, the user interface is potentially a limited 5250 or a 5250 enhanced with RPG Open Access. That's the technical view, but that's where the user interface is. What if it was a .NET program running Angular? What if it's some kind of framework above this That's all available, and it's your architecture, but this is just architecture. Technical details come a little bit later. And then orchestration and mainline. In one instance, we had several screen programs. We had one mainline for each of those. And then some of these services need to be available to other places. And so we would have at that same level, the interface level, just some APIs or web services. Primarily, historically, they've been SOAP. Today, most people treat them as REST web services because those are now secure and scalable and HTTP, which is pretty cool. So that's our architecture. Now, between each of these, for example, say we have a constraint on the database that needs to fire and tell us there's some problem. We need to communicate that up to the coordination level, the orchestration level, or the interface level, and that's what the cross-cutting is. It goes across all layers. It could be security, for example, in the other one, it was something to do with even operations, and DevOps could be built in here to support all of that. So these are functions, services, things that happen across all of these different layers. We need to understand that there will be a case for that, but it's a limited functionality. It's not a whole thing. So that's your whole IBMI reference architecture. Now, we say IBMI, even though it's not necessarily, but we know how to do this with IBMI. So if you are building an IBMI architecture, this fits really well in a modern architecture. It's a destination architecture, and we'll be talking about coexistence with existing applications in a moment, but that's generally the bigger picture. So, Mike, what do you think about this on first blush?
I like it. I especially like the fact that the cross-cutting is illustrated as kind of small cylinders as opposed to large objects. It implies to me that the cross-cutting is like the exception as opposed to the rule. I'm assuming that may not necessarily been the direct intent, but that's definitely the way I'm taking it in.
It is, and for example, we often use SQL global variables. So what we do is at the very top, we will set a global variable of who's the user that called this, and in the database layer, we'll go get that global variable and shove it into the database and say where it came from. So we're able to cross-cut and communicate information that is global and doesn't need to be transferred through each of the layers. Alternatively, if I have a constraint that says you can't delete that because there's a foreign key constraint that's preventing you from deleting that row, it needs to then be told to that and then communicated back up the pipe, if you will, to that top level that then can decide how to communicate that to the user or decide what to do on the response of the API.
Okay, and it might be too soon to throw some of these things out there, but two things that come to mind. Number one, how would a stored procedure be implemented in an architecture like this? Number two, if I have a data replication scenario, for example, we get into coexistence, and we can push that off. We get into talking about coexistence, but where do those kind of fit into this type of an architecture?
So the data replication comes a little bit later. We'll go through that. Okay. As far as stored procedures go, I actually have a way in a chart coming up that shows how the fabric of this is built on IBMI, and I'll answer that question right there. But they are part of it because that's a function we have available to us on IBMI.
Yep, cool.
So that's our big picture of the architecture. We have a lot of people who build this with N-tier rules, which says that from the interface layer, you can only access anything below it in the business processes layer, from the business processes layer through the database access layer, and then from the database access layer directly to the database and through views. So, for example, you cannot, from an API, call or access a view directly. Now, if you're using MVC rules, it's a little bit of a wash. You should be able to then, from an API, call a database access layer function. You probably still don't want to directly access the database. You still want to go through a function that would do that. But then MVC rules, basically, it's a bit of a free-for-all. We haven't found that fits really well on IBMI because generally, because of the binding, and we'll come to that, because of the fabric architecture we have underneath, can tightly couple all of these things, you don't need it. Now, if you've loosely coupled things, potentially MVC applies. And so if you took this architecture and moved it to another platform, you might have a little more opportunity to do, you know, pure MVC rather than a modified version of it, if you will. But again, the architecture is not designed to be restrictive. It's designed to be informative and to help us understand where each of these bits and pieces feed. There's a lot of work that has to be done underneath to define how these things are structured and what level of granularity you have your services and stuff like that. But MVC is really not something I've discovered in the wild. Mike, have you found anything about it?
I mean, with regards to IBMI or RP?
Yeah, with regards to IBMI, very few people use it in my experience.
So in my experience, I find very, very many people who are, but that's primarily because I spent the last 10 years supporting PHP infrastructures.
Okay.
So that kind of grew up there. In fact, the PHP world is kind of, you know, MVC is kind of where they start now. That's where the training wheels are now, as opposed to being the advanced class like, you know, 8 or 9 years ago.
Correct.
Now they're getting into object request brokers and that kind of nonsense. So I mean, they're kind of, you know, moving off into a new universe. But MVC is still, you know, widely adopted and used there.
And ultimately, if you look at model view controller here, you know, you really got the view at the data access layer anyway. You've got the model, you know, the view at the top and the controller in the middle. So you really do have an MVC structure. It's just how you use it in between. And that's why we found, in this case, N-tier tends to be the more popular one. We can pretend that you can name it whatever you like, but it's meant to be a guide to help you, not a restriction, you know?
Yep.
So here's an architecture example.
I'm sorry, getting back to MVC for 1 second. I mean, when you talk about MVC, you're talking, I mean, we should probably clarify, you know, the reference architecture here is this is a combination of data and business logic, as opposed to just data, as opposed to just data access or something like that. And you know, when you're talking about MVC, you could easily make the argument that in an MVC environment, all of what you're seeing here is the M.
Yep.
The V is your JavaScript, HTML, all that kind of nonsense, and then the C is simply your routing patterns. So,
yep.
Yeah, you know, I think that would be kind of a comfortable way to look at it as well.
Yep. Now, one of the things I've just discovered in conversations, and in fact, I'll go back in here. One of the things I've discovered in conversations is for when you're building architecture and you're building layers like this, there's a thing called the facade, and I haven't represented it in here with any images, but facade is really what is above the layer to represent that layer to the next level. So for example, in IBMI, when we, and we'll talk about that, we don't often need a facade between layers, but facade might be a way that we can actually, you know, represent one layer to the one above it, or to the rest of the world, if you will, and maybe more handy in an MVC environment.
So the argument, and to support that point, when you go down to the database layer, the view is essentially the facade for that layer.
It is, and you know, right now, if you look at the database access, if you wrap those functions into modules into a service program, the service program is essentially the facade, if you will, because it's the way it's represented. If I'm going to represent it to the outside world, I need a different kind of facade where I might be able to do some kind of extended services or web APIs or something. But that's a new function or new terminology that I haven't really addressed in here, but it fits and it talks about it. So let me go to this example. This example is, let's say, orders. And if you have a look at the, down the bottom, we would have the order detail and order header tables represented by views. In the database access layer, we would have the order header CRUD and the order header list. Then you would have the order detail CRUD and the order detail list. So the database access layer, it's representing the tables. And then the business processes layer would be looking at them as an order. So you would have an order CRUD function that would say create order, which would then call the order header, and then the number of order details for each of the rows of the items, and then any other things, order header comments, order detail comments, any other normalized tables would also be accessed through that one. So when you're talking at the level of the business processes, you're looking at it at an order level, an entity level, or a transaction level, if you will. And then above that would be services. So if I wanted to expose a list of orders out to the outside world, I'd have an API that would do that, or I'd have a, you know, some kind of screen user interface function web page that would list the orders, and I would access the order list service in the business process layer, which would do everything. So that's an example of using it in a tightly coupled IBM I architecture reference. That's just an example. It's not again, these shouldn't be restrictive. So we're going to talk about Coexistence Fabric. We're going to send that off to a different video. We're going to have a whole conversation about how in IBM I architecture, Coexistence Fabric between the current and the modified or modernized or evolved applications. And then Mike and I will argue about whether that's temporary or permanent coexistence. But that'll be a separate video, so look for that at FrescheThinking as well. For the next part, we just wanted to uncover a little bit more about the technical details of an architecture fabric. So for example, when I create these functions on IBM I might have RPG and COBOL at any of the top levels, or at the business processes levels and at the database access layer. And I can actually bind all of these together so that when they come to runtime and they're bound, they work more efficiently together instead of having to go through some other different facade. So they're brought together. That's an IBM I sole architecture fabric. That's not available on other platforms in quite the same way. ILE provides that. Now, Mike, you asked about stored procedures. And in this particular instance, we have an opportunity that stored procedures could be at any of those three layers up there. They could be at the interface layer. They could be at the business processes layer. Generally, they're more often used at the business processes layer, where a stored procedure is created, and then through a IAS or IWS, it's exposed then through an API. So generally, we don't bind those into a process with the other functions, so that becomes a bit of a separate thing, and we would do it for a different reason. So if I had a function available, now some of those reasons are maybe I'd like to use SQL, maybe SQLPL as my way of building that interface, or maybe a stored procedure was written for a different language that I want to be able to use, and maybe they're part of the architecture because they are available on IBM I, and that's a cool thing. So the question then becomes, how do they fit into this? They fit into this, but they may not be bound as tightly as this architecture fabric is done. But because they're a technical solution, they fit in many places. Generally, though, I've only seen them at the database access layer when people are using pure SQL, not things like RPG and SQL or COBOL and SQL. And I've also seen them at the business processes layer when people didn't quite understand how to bind multiple RPG modules together, and they created a single stored procedure to do a single function, and it was very simple and easy to do, and they exposed it as a service. So I've seen that, but it's generally not bound into this fabric quite as easily. So that's my stored procedure answer. But again, this is not a dictation. It should be, it should be flexible to accommodate whatever your technical solution needs are.
Right.
So it makes sense? Answer your question?
Yes, sir.
Cool.
No, I like it.
The next part of it is obvious, and this sort of seems like a bit of an interesting thing. It's a bit of fabric plumbing between that business processes layer and the API interface layer, and it's done by IBM, which is IWS and IaaS. But there are functions there that are built, and they need to be part of the solution. For example, if I build a integrated web service, and I build that service with a wizard, and it's now exposing some of my functions that are available at the business processes layer, then potentially now that service has to be part of my solution, and it has to be able to be promoted, has to be able to be, debugged and tested and all those kinds of things. It has to provide the right functionality. Now, if you're going to do that, you're going to need some extra things. Like if you're creating modules in RPG, you'll need to make sure they're compiled properly so that PCML is produced, which is the program called markup language, so that can be used for the wizard, or you can manually create them. That's a little more effort, but there's work to be done between the layers. And it's actually only providing for that communication between the layers. This is actually not part of the application, but it's part of the architecture. So it's a service functionality. So I called it plumbing. I tried to call it wiring, but it's a bit of that in-between stuff that we need. So it's really plumbing, and it's really called architecture fabric is probably the best word that I can use for it. And it's needed in between layers. And it's not quite the facade of the business processes layer, but if you would like, it could be put there. But ultimately, you end up with a service, and the service is then available to be consumed from other platforms or other applications.
So something else that could actually go in that layer, because when you say IWS and IaaS, there's a question that it's kind of like Java or nothing, you know, and certainly that's what IBM's provision is Java based. That stuff's written in Java. I'm not trying to say it can only be consumed by Java. That stuff there is Java centric, which is fine, and that's great. That's what IBM does, and they do it very well. But there are other solutions can exist at that layer. For example, in the PHP realm, there's an open source framework called App Agility that was sponsored by Zend. I have no idea what the status of that framework is. I'm assuming it's still supported today. And that would be another piece that could exist at that level, because you know that App Agility is designed to talk to your database or your processes, and then provision a service, which is kind of like what IWS and IaaS are doing in that respect.
And that might be a fabric between the business processes layer and the database layer too. We could leverage that there as well, depending on what your business processes layer are. While they're primarily RPG and COBOL inside of IBM I, we can also run PHP on IBM I where that architecture fits, but the artifacts may not be what you see as traditional business processes, because they may be built in some other language. And PHP is a really prime example of that.
Well, and I think one of the things we need to consider is that because of the open source technologies, they tend to communicate, because the open source technologies tend to exist in pace.
Yes.
The rest of this stuff, the rest of this architecture, a lot of what this exists in a native environment.
Yes.
We've got this Gulf of Sidra, so to speak, between the two.
Yep.
Or, how do we communicate across these two? And right now, the only transport mechanisms that we have, aside from literal transport mechanisms like FTP and that kind of stuff, certainly anything that's IP based, DB2, there's DB2 artifacts between the two. IBM is about to announce, very soon, and it's one of the worst kept secrets in Rochester. Jesse Brzezinski's told me I can shout it from the rooftops if I want. Is that IBM is going to start moving towards provisioning ODBC as the connection mechanism to DB2 on platform.
Cool.
So they're literally putting the ODBC driver in pace. And the reason for that is that way IBM Rochester doesn't have to support a separate DB2 driver for every technology that comes along. If that technology comes to the platform and already supports ODBC, it can take advantage of it and use it.
Perfect. And yeah, that comes a little further. I guess this is actually at the moment the native side of things. So bringing that up is perfect. I've got some slides on that. We'll have a further conversation in just a minute on that.
Fair enough.
Perfect. This is an example of a bit of plumbing that we put in at a customer where we had a service that was exposed. And that service was actually not through IWS, but it was created so it was available through IaaS. And in fact, there are also Java programs. There's Java functionality that can be called from outside. If you want a Java program to call a stored procedure or service program, you can do that. This was a front door where it actually said all of these services would go to one front door with an identification and the URL of what it was looking for. Did it need to look up a list of orders or did it need to get an order? And in that consumption, that front door program was called, and it actually had a couple of jobs. Its first job was to do authentication, and it received an HTTP token through the front end call, which was from a .NET program. And that token was actually on a Microsoft AD Active Directory server, and so we had to go consume that from somewhere else. So we did that the front end so that none of the services in the business processes layer had to do that. It was done already. So security-wise, the business processes assumed you only call me from that or from one of my other programs, so I'm secure. It also did something called an SQL injection check, which was interesting because we weren't actually passing SQL down through the layers, so we were actually able to cheat. But it did do an SQL injection check there. We didn't have to have that security for our secure architecture, but for some people, they may want to do that as well. And that's also part of the architectural fabric or the plumbing. And then it may be that we have all of these layers on one platform and then the database on a different one. And we need to be able to communicate there. So we need a plumbing between them, between the database access layer and the database. It may be we need plumbing between the business processes layer and the database access layer that are on different platforms. We've got to consider all of these things. And now we come to the IBM I and other platform, which could be IBM I and another IBM I, or it could be IBM I and PACE, which is IBM I. So there are two types of rules here. One is the top-down, and then the other one is the cross-platform. And the web service consumption is done usually for the cross-platform. So if we have these two side by side, whether they're both IBM I, they're both, one's IBM I and one's PACE IBM I, one's another thing, maybe .NET or Oracle. Top-down is good for local. On local, the rules apply from top-down quite easily. And because on IBM I, we have the ability to do the binding, we have ILE, it works very, very well. But if I want to go to that other platform, I may have to go from the top and consume that something, some service or function, and I may need, and generally we have that ability. We can just consume a web service through RPG. We can do that already, and that makes our life a little bit easier. But we've got to understand these rules in a little bit deeper. So the other choice is maybe I have two platforms side by side. Maybe IBM I to IBM I platforms, maybe two partitions, maybe two applications, and we want to talk between them, but keep them separate somehow. We could potentially call and follow the top-down rules. So if we have the right coexistence, we may be able to call them. And traditionally, IBM I says call program. If these are all built as service programs, then we may have to bind them a little bit. And so the binding makes these things tighter, and therefore they're all part of, and that's an advantage of IBM I, is that it's all one thing. If I have a vendor who uses a database on IBM I, it's the same database, and I don't have to go and do things differently. I can leverage that. And so I can build my own services around it, or my service programs and my modules, or I can access theirs by binding them together. So there's a lot of rules to think about with coexistence. And the local rules are the top-down. Those are fairly straightforward. We've covered all of them. But now we get into the challenge of coexistence from a distance. And I'm trying to work out how to deal with this properly. But that thing in the middle is the wall that, Mike, you and I talked about. It's like I have a wall between them. I simply can't go through that wall. And if that's the case, it's pretty easy. From that top layer, I will consume a service on the other layer, which means that as far as one side goes, we don't actually see the rest of the architecture. That's all we need to see. We don't even need to know that it exists. Correct. So the same as the AD, the Microsoft Active Directory, we didn't care where that database was stored. We just consumed the service to say, are you valid? It's that kind of thing that's at this level.
Well, and to support that, in addition to that, I think that's a huge point to keep in mind, is that, you know, we're using what's already there. But again, to support that is, now we don't have to manage any kind of exceptions. We're following the rules. We're following consistency on both sides. Yep. Of the fence. And in a perfect world, we'd like to do, we would certainly want to lead with this kind of an approach.
And the interesting part is, for IBM I traditional RPG developers, the thing on the left is what they need to see, and they get confused if you show them the thing on the right because they can't see the stuff that's happening under the covers. And this is modern architecture where things are modular, and all you need to know is what the input is, what the function is that's happening, and what the output is, and you rely on that.
And so that really brings up a good point, and I want to throw this out on the table. We can either table this for a completely separate video, or at least I want to get your initial thoughts on it. And that is, you know, my recent research into microservices, for example. This is the rule in a microservices world, right? Service talks to a service. You don't get anywhere near the underlying, infrastructure. So this is the way you do things. But there, part of the culture that we deal with in the IBM I community, and this is, I think, it's both a good thing and a bad thing. And that is, the culture in the IBM I community is we're very proud of our operating system.
Yep.
Right? We love our operating system. We want to advocate for it.
Yep.
So what ends up happening is that when you show something like on the left to a typical IBM I person, they sit there and they're like, wow, I'm going through a lot of extra work just what I normally do. I just want to chain to the file, and we kind of celebrate our exceptionalism at figuring out, quick and dirty ways to save half a nanosecond or something.
Yep.
Right? However, part of where that divide between the IBM I community and the rest of the world, I think, exists, and where it's getting bigger, is in the world of microservices, because it's been my observation that in microservices, The goal there is to diminish or marginalize the operating system. In other words, I want to build my infrastructure, my Node.js, with a Postgres database, but I want to be able to drop it on any operating system. I want to be able to drop it on AWS, and if they piss me off, I want to take it over to Google, and if they piss me off, I'll take it over to Microsoft, and so there's this belief, there's this religion. It's very fervent religion right now, and I don't see it going away anytime soon. Thank you, Netflix. But there's this religion out there that says, forget the operating system. The operating system gives me no value at all. And I think that's fair in a Linux space, right? Because that's the whole idea of Linux is that it's just this very thin veneer, and everybody's treated as a ubiquitous thing. And so now we've got another conflict of culture that we deal with in the IBMI community, which we still want to balance that, because you know what, that thing on the right, it may very well be a microservice that we have to deal with, whether we want it or not.
Yep. So it's interesting because microservices have been you and I have had these conversations about where it started from, and it's been fascinating. We've gone through it. And in thinking about it, there's a company we'll talk about at some point from Denmark who have quite an interesting environment where they've built essentially an enterprise service bus for IBMI applications to allow you to do things. And in reading his stuff and looking at it, I'm trying to find out where in this architecture it fits. And I actually think his ESB is a transport mechanism between that API layer and the business processes layer. And that's it. But it could be plumbing between the business processes layer and the database. It could be all of those things. But he talks about microservices like, and I tried to have him understand that the argument is not about whether or not they're microservices. Because if you look at the argument about microservices, there are two things. One is the granularity of them and the scalability of them.
Exactly.
We have the ability to do both of those. What we don't have the ability within the traditional IBMI reference architecture, or the architecture that we build, is to take that stuff away and put it somewhere else. So the interesting part about it is they talk about it being platform independence, but they have not got it because they have language requirements.
Right.
They're actually stuck in a language or a technology. Whether or not that technology can be run on many platforms, we could definitely bring microservices and run it on, potentially in Pace, but also on Power. We could potentially run those microservices, definitely. But the answer is we can also expose services that are at a granular level that can be deemed to be microservices and that can be consumed in bulk simultaneously, synchronously or asynchronously, however you want to do it. We can do all of that. We have that capability. So from what it does at a granular level and how scalable and we add reliability and all that kind of stuff to it, we have the ability to do microservices, but it's not the microservices that it's like all the words that are used out there. What does modernization mean? It means something different to different people. If you take the microservices to be stuck into an architecture or into a technology that it fits on multiple platforms, then you stuck it into a technology. And so I think when you're building an IBMI reference architecture or a destination architecture for all your applications, and microservices are now part of it, consider that what is the functionality being done? Because we are actually leveraging IBMI for the long term in many cases. And it might be that all IBMI ends up being is a database server. And you either go directly to the database through services on other platforms, and then you can build your AWS version of microservices. Or it could be that we supply all the services all the way up the tree here, and we expose services at a very fine granular level that are microservices and that IBMI can handle. And traditionally, one of the problems has been is people bring Java applications or something like microservices to IBMI and go, it sucks. And we say, why? And they say, performance. And I said, well, did you tune the work management to handle the load you're giving it? And the answer is no. Well, then it's going to suck because it's primarily batch and interactive, and HTTP workload or a services workload or a database workload needs to be tuned. And so you've got to know all of those. So I think we can do it. I think that it's up to us to maybe change the conversation about microservices to say with IBMI, yes, we can deliver it through Pace, through other alternatives, but we can also deliver the equivalency of the functionality and the scalability And if that's what you're looking for, it doesn't stick you to a technology, because you could take those and move those if you like. But ultimately, we are leveraging the power and the reliability, scalability, and the future of IBMI. So,
well, and one thing to keep in mind is that, from a microservices perspective, if you're consuming, you can't tell something as a microservice. It's just, right?
Yes.
It's the other side, it's the provisioning side that really defines what microservices are.
And it's like selling IBMI. Why would I buy IBMI as a new platform in 2019 or 2020? And the answer is because of the delivery. And if you listen to people like Liam, he says the answer is the database. And but ultimately, it's the business value that you get out of it. So why would I carve up and deliver all of these things that are somewhere in the cloud and all over the place that I don't really understand, and all I've done is plug them in and I can replace them because they're cheap? I'm not looking at it from a business perspective of what is it that I'm providing. I still have to do the business functionality, and microservices may be part of it. So if I've got the business functionality on IBMI and I'm delivering the equivalent of what a AWS microservice is, then we're delivering microservices, and the conversation just needs to be aware and understand that. And I think that that's been part of the problem, is that I know you and I both had conversations with different customers who said, but I want microservices. And for me, I've stopped arguing and I've started saying, well, what do you mean by microservices? Right. And then that changes the conversation.
Yep.
Because if it's a business reason, it goes back to anything. It's a business reason, not a, and there's architecture involved here that can handle microservices. But the technology part of it is a different conversation, and that's fine. And look, as people are turning microservices into a commodity and they're able to generate them, that's what's happening on IBMI anyway. People are starting to, like we do that. We generate some of these things. The database access layer, we generate it. There's no reason. It needs to not be handwritten anymore. We can completely generate all of that. We can completely generate the coexistence fabric. We can completely generate the cross-cutting, all of those kinds of things. We can generate all of that stuff. It's becoming a commodity, and it will. In the meantime, we'll need help to be able to do that. But as this all becomes a commodity, if all you're doing is just exposing the same things you've always been doing, at least now you have microservices and you're leveraging your IBMI skills and your IBMI, processor and all that kind of stuff, So.
Yep.
Good question, and related to coexistence. But now I'm going to ask you a hard question.
Okay.
So what if I went down a level on my IBMI and I wanted to consume something that was somewhere else, a service that was available somewhere else? Do I make my architecture handle that by saying that at that services, the business processes layer, I can consume it? Or should I just go back to, no, only can be done at the top level, so I'm going to need an orchestrator to call the next level and to do that work? And then I'll ask you this. What if I wanted to do that from the next level down?
Well, if you're going to do that, why not just go right to the database?
Correct. And so I think that we have to, at least in building this architecture, we have to put some rules in place. This is a very easy rule to implement. This rule from the business processes layer is acceptable, and some people are doing it. I think once you get into this layer, you're actually breaking the rules. I don't think you really understand architecture, and at this level, you should only be talking at the table level, and that on the right is not a table.
Right.
Even MVC.
I'm sorry?
Even MVC.
Right. Regardless. Because I've seen MVC architectures that consume services on platform, which is, there's first of all, we have to stop and think about why are we looking to put the rules in place in the first place?
Yes.
And because we want to have a structure, and with a structure we can enforce rules, and we can have, and everybody kind of moves in the same direction, right? Yep. Everybody's following the same. I may not like the fact that I have to go to the corner, push the button, and wait for the light to turn green before I cross the street. I can cross the street right here.
Yep.
And you know what? And yes, you can, and yes, you'll get away with that a bunch of times. But sooner or later, there's the thinning of the herd, and you're going to get hit by a car, or a policeman's going to write you a ticket, or something along those lines. It's kind of like pay me now, pay me later kind of stuff.
Yep.
And I think back in the day, performance was the number one excuse for going around a lot of these things, because I'm throwing a lot of load at this, I'm throwing a lot of this at this, I'm throwing a lot of that at that.
Yep.
I think performance, in the Intel space, that's I think what we see microservices addressing there is the elasticities. They're scaling horizontally so they can satisfy the demands on the load.
Yep.
IBM I think we've seen people have upgraded to Power 8, to Power 9, and now they're they've got more horsepower than what to do with. And IBM has even gotten out of they used to have this thing called the 795.
Yep.
What was 795? It was essentially a mainframe, but it was essentially a massive IBM I in a mainframe chassis.
Yep.
And IBM doesn't. Well, when Power 8 came along, they didn't come out with an 895, and everybody's going, "Whoa, why don't you have an 895?" And I think I don't want to put words in Allison's mouth, but I think as Allison said, we don't have any customers who are asking for that kind of horse. Or it's such a corner case that it just doesn't make good business sense for IBM to invest in that if the one customer who might buy it, or no, they're going to sit on their Power 7 for another 10 years.
Yep.
So you've got those kind of things out there.
So making those rules also helps us in the development cycle as well. And
that's it.
It helps in generating code. It helps in building test harnesses. It helps in making sure that the in and the outs and the function is performing the way that you want, rather than, what you're doing is essentially cross-cutting illegally without a purpose. And the purpose is, and we had this in a customer where the programmer said, I'm in the top level, I'm just going to call the database. It's a tradition, not a requirement,
And you're bringing up a really good point, and that's DevOps. And DevOps needs some level of predictability in order to be able to leverage those key components like you threw out there, like test harnesses and stuff like that. One of the things that we need to do, and there's a kind of a Twitter chat going on right now about this within our community, is that we need to embrace DevOps behaviors more. Yep. I don't expect any IBM shops who've never had change management to drop what they're doing right now and go right into a pure DevOps architecture. Yep. It could be approached over time, but the reality is that you're in order to automate something, you have to have something straightforward to automate, and that's really what DevOps is all about. And consistent. The more exceptions you throw at this, the harder it's going to be for DevOps to keep up, and pretty soon you end up marginalizing the DevOps. Yep.
And as we move forward here into the world where we're doing more hosting and there's more servers out there, there are more service and hosting providers and infrastructure as a service providers and platform as a service providers who can actually do the DevOps side. They can do the ops side of the DevOps for you. And so you have to be working with them. So you've got to provide them the functionality. And so doing your own change management really is sort of a step back into the 20th century. And so I think that things will change here. And I think some of that's going to start to impact an individual architecture as well as to where you can call it. And it may be, look, if I'm throwing it over this wall, I've got to go and consume something at the high level. So I'm going to have to put in some rules that will handle that. So each of these are possibilities. None of these were actually designed to say you must, but we wanted to open this conversation and continue with it. And I
think if we take the medical analogy, it'll help. All right, and that is, treat what's on the left-hand side. That's the human body.
Yep.
Right? And who's coming in from the right? It's a doctor, right? And the doctor's first order of business is first, do no harm, right?
Yep.
Now, if you talk to a surgeon, the surgeon can't wait to cut you open.
Yep.
Right? But the point is that, is there a way that we 99 times out of 100, our first tendency should be, can we satisfy the need from the top layer?
Yep.
Because it's going to be the consistent approach. That's what infrastructure is built for. And now we can provision that. Now for that 1% or less than 1% of the time, what are those corner cases that are forcing us that we can't use that top layer approach? And I think you and I have kind of gotten into a discussion about temporary coexistence versus permanent coexistence.
Yep.
And I think my tendency would be, I want permanent coexistence to stay at that top layer if at all possible.
That leads into the next part of the conversation.
Platforms, I might be able to make exceptions for. Go ahead.
And that leads to the next part of the conversation. Should I actually not go through from one side to the other from the distance? Why wouldn't I consume from my left side, my interface layer, directly into the business processes layer on the other side? And that means I need to have that yellow part, which is a different kind of plumbing between them. And they have to be, and this is more tightly coupled, and they have to be much, much, much closer than what is traditional. If I'm going to work on something that is, you know, in the cloud, I probably wouldn't have this kind of relationship with these two architectures, and I wouldn't be able to talk to them.
Yeah, because from a cloud vendor, you're not going to get to that lower layer.
Yep.
If I'm deploying an application to the cloud, everybody's coming through the top layer because it's just, you know, it's going to be the law. It's the way I'm going to rule things.
But if these are closer, I might be able to do this. But it's got to be much closer.
There's always going to be those exceptions. Like if that's a Microsoft SQL Server .NET infrastructure on the right, and there's my IBM on the left, and we're both inside the same firewall. Wow, it would be nice if I could just reach in with an ODBC connector and talk to SQL Server as opposed to having to go, you know, reach around my back to scratch my elbow.
Yep. And then the same thing here.
Yep.
With and this may be more, and in fact, I think the next one is below. This may be more data replication kind of things, and this is where we have extra technology. Sorry.
And you know my religion on that, and that is, you know, when you're talking about migrating systems, and I'm talking I to I or .NET to I or I to .NET, whatever it's going to be, that tends to make sense because your intention, right, is that the dotted line is going to go away at some point.
Yeah, so if this is a permanent coexistence, it has to be considered that we've got data duplication no matter what, and there's a cost to you to backing that up and making sure that that's synchronized.
And deviating from your DevOps, right?
And there's
around your test. You know, all the work you put in that green layer on the left-hand side for your test harnesses and all your DevOps infrastructure is now negated by that dotted line that's going right after your database.
Yep, unless I duplicate it on the other side or have a tool over there, it just adds complexity. But, and I agree with you, I think that this is definitely a temporary coexistence, but if it's going to be permanent for whatever, you've got some cost. Now, one of the things may be, if I look at this, I actually think this is a microservices architecture.
Okay.
But what we're missing is the 1,000 other versions of this. So, I mean, if you think about Google, they have this because they have to have data duplication in places that is multiple. And then they have to have access to those multiple data duplication, you know, duplicate data. And therefore, it depends on your application. But if you're talking about your business, it's a very different thing. If you're talking about a system of record and you want to store that system of record, that's a set of data that you don't want to have multiple versions of that people can screw up. If that link in between is somehow compromised, one of them is not right. So there's a ton more architecture, infrastructure, and security that's required for this kind of thing. So building the yellow is meant to represent a coexistence fabric. And, you know, if it's a temporary thing, this is not an issue. For the long term, it becomes a huge, huge issue that you've got to consider. So we think that doing something like this at the bottom level, when you're doing it at the bits level on the disk. So something like flash copy, for example, is often used. And sometimes, you know, just keeping sync at that bottom bits layer, that's a whole different process. So that's architecture that's already sometimes built into IBM. If it's two different platforms, yeah, you're going to be struggling. But for IBM, it might work for you. So that's the short version of the reference architecture. We wanted to do this again to start a conversation. This is not a dictation of an architecture. It's for people to ponder, to use, to leverage. And, Mike and I have had lots of conversations about this, and we've got, there's a team at Fresh who are discussing this on a regular basis. So feel free to, stop us anywhere you see us in public and have a chat about this. We recently had a chat about this with our customers at the RPG and DB2 Summit. And it was really interesting. It was so far above the head of the techie people in there that they had to pause and think about it. Mm-hmm. So I'm offering this as a starting of that conversation to continue it, because once we had a little bit of a chat about it, it seems that it's not that difficult at the top level. Some of the details are the hardest part. And again, this is not restrictive. It's meant to be informative, and we use this as our destination architecture in a lot of customers as we modernize and strategize for them. So there we go. So thanks, Mike. And I will post this soon.
You bet.